Hello, students and YouTube learners. This is Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California. And I'm here now with the second video on C++ functions. In this video, we'll discuss some very important topics like pass by parameter passing mechanism to the functions, pass by value, pass by reference, and some technology like function prototypes. So let's begin. This is the second concepts video, and after that we'll do some concept strengthening videos and some more new technologies, and finally the design example. Okay, so let's do a review first. Value returning functions only return a single value to their caller, and value returning function have a special call syntax. They are called as part of an expression having assignment operator. Function call is placed to the right of the assignment operator and return value to the left. Return value is stored in the variable on the left side of the assignment operator. And void functions are just called like any other program statements. Obviously argument is passed, but there's no assignment operator in void function calls because they don't return anything. Okay. We designed a cube function in the last video. We will code that and run our code, run our cube function design in the last video. We'll show how the transfer of control takes during function call, and we'll also show a value returning function and a void function. And for that we need to go to our compiler Xcode. So let's go to Xcode. Okay. Right here. Okay, so I showed you this last time in the PowerPoint, of course, that I'm going to have a function called cube. It's taking an argument arg. Purpose of this cube function is going to cube this arg and return the cubed value. So algorithm is very simple. We take arg, multiply itself by 3 times, store it in the value, and return the value. But we do have one more function here, print. Print has a very simple algorithm also. This is a void function, doesn't return anything, so it doesn't have a return statement. And it takes a value like data, which is double type, and simply prints to console. Both of these functions are called from the main function. Calling block is the main function. So I have a variable into which cubed value of var will be stored. So I ask user enter any real or whole number to be cubed, and I store that in the var. Then I call the cube function with this value that has been stored in the var, and at that time control transfer to cube function, and we'll see how line by line we do that. Okay. And then I print this var and cubed, so the print function and control is again transferred to the print function, and finally we end the program. So in order for me to show you transfer of control, I have to put a breakpoint, and now if I click here, my program will run, and one thing that will happen, you see this green band? If I click on this, it's going to go line by line, and if I click in this arrow, it'll actually get into the function. and that shows us the control of the transfer. Okay, so enter any real or whole number value. So I'll enter that 2.01. Okay, something happened here. I suppose I have to do one more of this. Okay, let's try again. 2.01, and now I'm here. Okay, now I want to get into control of transfer. So notice that var has a value of 2.01, and I'm going to this function. The way it works is that this value stored in var is also copied into arg. That's how control of transfer takes place. It can take place in other ways too, but at least in this case, that's how it's happening. And if I click on step into, now I'm executing the first line of the cube function. But you can see if I place my mouse here, arg has the same value that was stored in the var. Okay, we are not in the scope in the var, so we won't see that right now. So this is very significant that during the course of execution of cube, 2.01 is stored in two separate variables. One var that's in main and one arg that's in cube function. Same value stored in two different variables. And you can say that, okay, how do I know there are two different variables? You can, in a minute, we'll print the memory address and you'll see they are different variables. Memory RAM is addressable memory, and if two different addresses are there, then we can easily say that there are two different variables. In any case, let's complete this first. My main goal right now is to show you control of transfer. So now I can keep going through here, and I'm back to line 27. Whatever the return value was, I should have stopped here and looked at the value, but it's 6.95, and once I go one more step, I'll see that that value got stored in the cubed. So if I put my mouse here, no, actually it's 2.01. Yeah, it should be 8 something. Yeah, okay, so my 6 point was wrong. Okay, so it's about 8.12. So obviously cube function worked, but again, my goal is more on transfer of control. So now I'm taking the value var, which is 2.01, and passing it to the print function. That means var should be copied into data, and that will happen if I take a step into. And if I put my mouse on data, it should have same value as var, and it does. 2.01. 2.0099 is 2.01, and you will see a printout here in a second. And then you'll see the cout. Yeah, you can see that 2.01 hat 3 to the power 3. And then once again, this time I'm sending value of cubed, which is 8.12, transferring control to the print function. Let's click here to step into. And you can see data has the same value as the cubed, 8.12. Okay. And it'll print 8.12 here. Yeah. So 2.101 to the power 3 is equal to 8.21, 8.12. Okay, and we can keep going. Okay, I don't want that. So let me finish that. So my program has finished. Okay, so I said that when this function call was made, whatever value var was, it was copied into arg, and that was used here. So what does that mean? That simply means that var and arg are two totally different locations in the RAM. They're not the same, even though value stored in them is the same. How can we show that? That's pretty simple. I can do that anywhere. I can print the memory address of var right here, cout memory address of var in main. And I have to cast it to long type, otherwise it would be hexadecimal, which is hard to understand. So and var. Okay. And then I print here the memory address of arg. So I can just take that and just change it just a little bit. Arg. So if these two memory addresses are different, and of course their values are same, I showed that to you a couple of minutes ago. But if address is different, that means there are two different locations in the RAM. What does that mean? That means that during execution of this function, I have two memory locations that store exact same value. That is called pass by value mechanism. We'll discuss that in more depth later. But it's important to understand that when control of transfer takes place, at least in this case, the copy of data is being made. Let's run it and you'll see this memory address. Okay, I should make it arg, sorry. And this memory address of var, they're different. Let's do it. Okay. 2.01. And we'll make this window a little bigger. Okay. So you can see that we can just compare the last 5 digits, last 6 digits, because up to then it is the same. 7555368, 7555304. Memory address of var is 7555368. Memory address of arg is 7555304. That proves they're two totally different variables, although they both have the same value stored in them. Okay, so this is the mechanism of transfer, control transfer to the function being called that I wanted to show you. Okay, so now we did that. Now we want to show one more thing, something called function prototype. Okay, so let's go back to Xcode again, and I want to show you something that's kind of interesting. Notice I put cube and print before main, but let's just, for the sake of argument, just for a second, I want to move cube from here and maybe even print from here to here, right? And take the print also. You can say, well, you know, they're the same file, so it shouldn't make any difference where they are. Well, let's try to run the program now. all of a sudden I get these red errors. And let's look at this error first. Use of undeclared identifier cube. A function is there and compiler is telling me I don't know what cube is. And then something similar will happen here. I think, let me go a little bit here. Yeah, it'll come up with that too. Use of undeclared identifier print. So it's complaining about that too. Why do we have that? We have that because there is a C++ rule that has been violated here. Remember from chapter 3, I said you can't use anything that's not defined. Define before use rule. There was another one, populate before use rule. C++ is saying that you can't use anything about which compiler doesn't know anything. Okay? We come here top to bottom, all of a sudden we use print. We have no idea what print is. And many times what happens is that if you have 100 functions, you cannot arrange them in a way that you know exactly which function calls which. The function that is called should be placed physically before the calling block. And that was the case. Like if I had it there, the cube function was before it was called in the calling block. And it was not a problem. Same thing with the print function, it was there before it got called in the calling block. But it gets very complicated when you have 100 functions, 200 functions, to arrange them in a way that function that is called is always before the calling block. So this is problem. C++ and C found a new technology called function prototype. So all we do here is we take the first line, the header line, copy that and place that here with semicolon, and in a minute I'll run it and you'll see error will disappear. And I do the same thing with this. Okay, if I run it, the error will disappear. There you go. See, all the error is gone, build succeeded. Okay, I don't want to run it because I want to say something about that. These two are called function prototype. So what are function prototype? And I'll discuss that in the PowerPoint in a minute. Okay, or let's just go there and discuss it. So function prototype is that we just move the definition of functions cube and print. When we did that, we had a problem, and we used the function prototype technology to avoid that problem. So what is definition of function prototype? Function prototype is a promise to the compiler that a name with the function prototype will be used before full definition is provided, and full definition will be provided later. We'll go back and see that again. Compiler believes our promise and does not give us a compiler error if function name is used before its full definition. But if full definition is not found, then compiler will give a link error. So prototype, in essence, is return type, function name, and data type of the argument in order which they are passed to the function. Okay, so coming back to the compiler, Prototype simply data type, function name, an argument, data type, an argument. So this is the promise to the compiler that I'm going to use names cube and print before the full definition of these functions. Don't give me a compiler. Compiler believes us, doesn't give the compiler. But let's see what happens if I skip the function definition and don't keep my promise. So let's just do that. And let's try to run the program now. Now build failed. And let's see what message that is. Okay. It's saying undefined symbol print. Does it give me a line number? Yeah, it gives me a long message, but really in your Visual Studio, you will get a message that it couldn't find the function, basically. That's what it is. Okay? So you have to keep your promise. You can't break your promise. Okay, so that's the story of function prototypes. Now, this is very important. Maybe I can type it. Let's go over here. Let me type it so that there's documentation. In CS1, function prototypes are always required. You cannot skip them. That would be considered bad software development. And all these exclamation is, you have to have prototypes. After prototypes, you can write function definition in any order you like, but usually people put them after the main function. Okay? So one way in which we did the function prototype was this way, that we took the header itself and put the whole header. Okay, this will work. Let me remove that. Yeah. But another way of writing prototype is that you can actually skip these arguments because compiler doesn't actually see it, and that works also. Build succeeded, program will run exactly the same. But the reason I use them, because when you write documentation on the function, which is done very often, we do need the name of the argument to talk about it. Conversation about argument cannot happen without some name of the argument, so we keep that. But it's not necessary. This name, and this name can all three be different. Okay, but of course, if I'm talking about function, keeping this name and this name same would be important. Okay, so that's the story on prototype. You can leave out the argument name, but don't do that because documentation cannot be done without the argument names. Okay, we'll be back to this program to do certain other things. Okay, going back to our PowerPoint. The program with many functions will look like this. You'll have your includes, you'll have your function prototypes, you'll have main function, then the other functions. We did the cube, you could put a square function if you like. So prototype, all the functions that come after the main are put here in this blue box. And after that, you can write functions in any order you like. I hope that is clear. Okay, let's talk about function parameters and arguments. Let's go back to Xcode for a second. Arg here is called a function parameter. But if you look at the main, var here is not a function parameter, that's a function argument. Sometimes it's called actual argument. If you're going to call this as argument, you call this actual argument. Actual argument is provided at the runtime. Its copy is made into this one. And it has certain issues, very important issues. We're going to talk about that in a minute. Sometimes this is called a parameter and this is called an argument. And we're comparing that in this slide here. So, classified by location, we have argument. They always appear in the function call in the calling block. Parameters always appear in the function heading or function prototype. You can think of parameters as metadata or formal argument. Metadata, formal argument, or parameters, same thing. But argument is actual data or actual argument. Metadata, real data. Let's go back to Xcode and see it. So basically, this is a placeholder into which copy is made. This is called parameter, and this is called an argument. Notice, this is very important for me to say. At the time of function call, data type is not used. Only the argument name. Formal parameter uses the data type and parameter name, but not at the time of the function call. This is very, very important to understand that. There's no double here, and I have seen this ugly scenario where people put double here. Don't do that. Actual argument, data type is defined somewhere, but it's not placed at the time of the function call. Okay. Okay, so I already showed you that when we passed var to cube function, where it was called arg, a copy was made. One more time. When I made this call, a copy was made of var into arg. This is a parameter passing mechanism that's called pass by value. Okay. So in pass by value mechanism, an incoming value of the argument is sent to the function that is being called from the calling block. And obviously, since I'm making a copy of this into here, this variable here that's being passed cannot be changed, cannot be affected. And incoming value to the function being called can be an initialized variable. It could be a named or literal constant. It could be an expression. It could be a value returned from another function. But the key is the value should get finalized before the value gets out of the calling block, because a copy has to be made inside that argument here. Okay? This is very important. A final value of the argument being passed must be computed before the call to the function is made. That means you can't pass a garbage. And we take some time to discuss that issue. In pass by value, the passed variable must be populated. You can pass a constant, but if you're passing a variable, passed variable must be populated. Now below, if you try to do something like this, it's a runtime error. That confuses students very much because they don't understand that pass variable must be populated. If I have code like this, a print function that gets a value val and thus being printed. But in the main, if you do this, int var, and then you pass var to the print. But here's the problem. Var contains garbage. It has no value. The behavior of this function call becomes undefined because what has to happen is that value, whatever is stored here should be copied here, but you can't make copy of the garbage. How are you going to make copy of the garbage? Now, in some compilers, it will not run the program. In some compiler, it will run the program, it will give you garbage value. So please don't do this. Understand meaning of pass by value. Meaning is it must have a value. It must be, a value must be computed before you make the function call. Equally bad way to fix that problem is here. So one more time, pass by value without a populated variable is undefined behavior. Calling block must provide a legal value. And students are sometimes not sure of this program requirement in the calling block. So they try something like below, which is another totally meaningless exercise. So they're not sure whether this has a good value or not. They'll put a C out and C in here. Enter value val, take that, and then print that. Well, that's an equally bad solution because this should have been taken in the calling block where print is being called. This is not responsible to print function to populate val. This should be populated before calling. So the contract is that function call contract is that val must be populated. So you can't fix this problem by this. You have to move this code in the calling block. Okay? That's how you fix that. You don't fix this problem by putting this code inside the print function. It's not print function's job to provide a good value to val. So this is not this is a bad fix. To me, this is just as bad as not providing, just having a garbage value for val. Okay? Real solution. This is the real solution. Make sure by any means or clear instructions to the user that a garbage value is not passed in pass by value mechanism. Think of pass by value with garbage value akin to giving someone a Christmas gift box that is filled with garbage. The gift receiver will not have no use for that garbage. Function getting the garbage value in pass by value parameter has no use for the garbage passed to it. And that sadly and badly breaks the function call contract. Function call contract is value pass must be a non-garbage value. All right, I hope I have clarified this, emphasized this enough that nobody will make this error. Okay, next issue is popularly called by pass by reference, but we're going to talk about this in a little bit more in a different way. In C++, we have mechanisms available by which we can give additional names to an existing variable. This mechanism is called assigning a reference. For example, let us view the code fragment given below. I have an int variable called int1 and I store 66 in it. I could do this. I could say int, this is called ampersand sign, int2 equals int1. The meaning of that is that now all of a sudden I've given another name to this memory location, which was int1. So int2 is another name for int1. And now either name can be used for the memory location that is storing 66, either int1 or int2. So int2 is an alias for int1. One example of alias is a situation where, for example, a student may have different names at home and school. Aliasing then allows two references or two names for the same person, or in C++, two names for the same variable. We show that in Xcode and a bunch of other things that are associated with the reference. Let's go to Xcode. So now I have to rename this one, so I don't want to run this. And code this one in and run that one. So, so it's the same thing I showed you in the PowerPoint. I have int1 memory location where I'm storing 66. And I create a reference int2 equal int1 means that now I have two names for the same memory location which stores 66. And then I can print them with two names, with name int1 and int2, and you'll see both will print 66. Now, how about the memory location? You'll see that memory location of both should be same, because all I've done is given two different names to the same memory location. So if I print address of int1 and address of int2, should be same. Of course, that's pretty clear here too. Now, since you have two names, you can change the name change the value stored, which was 66, through either one. So I do this, that int2 is 33, and print the value stored through int1 and int2, and you'll see they both give 33. Okay, let's run this one. So we have two names here, int1 and int2, and then I'm printing with both names, int1 and int2, and you can see both are printing 66. Then I'm printing the two addresses, address of int1 and int2, and you can look at the whole number, but two addresses are same. The meaning being that I'm just calling the same memory location with two different names. That's all there is really. Then I change through int2 name to 33. Original value was 66. And then I'm printing through both names. And you can see both names give me the same value, 33. And it has to be because it's the same memory location. Two different names for the same memory location. Alias, one being alias for the other. That's the introduction to reference. So this could be used as another mechanism for passing variables to the function. Let's see how that is done. Aliasing mechanism allows another parameter passing mechanism to functions. It's called pass by reference. If we place an ampersand sign between function parameter, data type, and variable name, that is a directive to computer to not make copy of the variable. Rather, the memory address of the variable in the calling block is passed to the function. The name of variable can be same in call functions and in the calling block, but we make a conscious choice for it to be different names to see that an alias to the variable name in the calling block is the one that is function parameter. And we show this parameter passing mechanism also in Xcode. Okay, so let's go back to Xcode. So So this time I'm already done with this. So let's rename this one so I can go to my next function. All these functions are in one block, one file. So so this time, this is the function I want to run. I have a function here called foo, which is passing the variable bar by reference. This means this is an alias for whatever calling block is using the function foo. And what does this do? It prints the memory address, but it just stores twice of the bar back into the bar. Now notice that this is a void function, it's not returning anything. But since this is the same variable as the calling block, by the time line 62 executes, its value will be doubled. Let's see what's in the main function. So in the main function I have int data equal to 5. I print the address of the data. Here I print address of the bar. Value of data I print here. Now I call the function foo. In the function foo, bar gets doubled, and then I reprint the value of the data here. Okay, and then you'll see how this got changed. Okay, so let's compile and run this. First, what is foo doing to the bar? It was 5 here. I printed through this line, it was 5. Now at this line, foo was called, so control got transferred here. This passed by reference, that means the memory address of data and bar is exactly same. Now let's check the memory address. Memory address of data in main is this number, and memory address of bar in foo is this number, and you can see that these two numbers are identical. I'll pause for a second so you can convince yourself that they're identical. Convinced? Okay, so what does that mean? That means that all I did, give another name to this variable called data. Otherwise, the same variable that got passed to the bar. And since that happened, here I changed the value of bar, made it twice, 5 to 10. When I print it after calling the foo, it should print 10, and it does. All of a sudden, this is very interesting. I have given another mechanism of passing a value back to the calling block. This is a void function. It doesn't have return statement, but I was able to change bar, give it a new value, pass it back to the main function block. It becomes additional mechanism of returning values. Okay, so let's see control of transfer in this case. Should I have breakpoint here? Delete. I should have it here actually. So let's see it. So once again, I'm here. I'll go inside the function here. Up to that, just watch the green band. There I am. And address of data in the main got printed. Now we're going to go into function foo. So click here. And I jumped here. Now notice that, of course, value here, okay, it's not printing value. Maybe I can click here, 5. So value wise, if you are passing value, it's going to be same whether you're passing by value or passing by reference. Passing by reference, you do have a choice of not passing any value. acts as a placeholder. But if you are passing value, then value stored is not the same. But there is a big difference. If I go further, memory location of data and memory location of bar is exactly same. That means they're the same variable with two different names. So in this case, copy is not being made. In pass by value, copy was being made, but now there's no copy made. It's exact same variable. That means memory usage is less. You didn't create another variable, you didn't make a copy. But more than that, now foo can change the bar, and the change value is immediately changed also in the calling block. And that's why if I come back and print the data, I print 10 because it doubled it right here. This is called pass by reference mechanism. All we do is put an ampersand in between. That means this will be treated as another name for this, which is being called here. Okay, this pass by reference. Quite and completely different from pass by value. All right. So we'll talk more about this. Let's go back to our PowerPoint. Pass by reference summary. You saw that placing a ampersand between parameter data type and variable name in function header changed the behavior of parameter passing. Now copy of the variable in calling block is not passed, rather memory address of the variable is passed. With hold on memory address, whatever changes are made to the variable in the called function, they are immediately made to the variable in the calling block as well. It's a live wire connection. Change anything in the function gets changed right away in the calling block also. And this is so because the same variable with two different names is being used. Exact same memory location is being used. Okay. So pass by reference situation could be seen by two pictures here. Calling block is calling this function. And one situation which we saw in the foo and bar, incoming was a good value passed to the function called, but then called function like foo changed the value and outgoing value got changed. So incoming had a good value, got changed, and it got changed in the calling block as well. But there's one more situation that can have pass by reference. It does allow you to not put a value in the incoming variable. That will be something like this. That argument has no value, it's just a placeholder. Now in this case there could be garbage in there. You know, garbage is never allowed in the pass by value, but pass by reference you can have an unpopulated variable. But unless you populate that variable in the function called, it's going to stay garbage, but you do have a choice of putting a new value in there. And then the variable that came unpopulated here gets populated and the value is changed in the calling block. So pass by reference is used in this way. You can have a function returning value and as many as you want pass by reference. So it could be used as a multiple return mechanism also. With pass by reference, you could return multiple values, although not all by return statement. Return statement only allows one value. There's a video after that. There we contrast this pass by value, pass by reference again. It's called a swap function. And you should read the ebook after or before watching this video to understand this a little bit more. Prep work in lab 6 will have a question about that. Okay, so example of situation 2 where incoming had no value, an empty placeholder will be shown in future, and pass by reference can be used to return more than value. We'll show that in the future video. Okay, goodbye from C++ functions video 2. This is Dr. Satish Singhal, PhD, Professor of Computer Science at Community College, Torrance, California. And my PowerPoints as well as that Xcode file, which will have all the codes I did today, will also be uploaded to your class website so you can see them all. All right, thank you. It'll take me some time to... Okay. I think I have to quit every